Have you ever tried to imagine what the universe might have sounded like billions of years ago? Not a sound as we understand it, sound waves vibrating through air, but a symphony of electromagnetic signals, faint and distant, traveling through the cosmic void. Some of these signals, emitted when the universe was still young, have traveled billions of light years to reach us here on Earth today. Each signal is a messenger from the past, a silent witness to an era that no longer exists. But what can these signals tell us? What secrets of the universe are hidden within those almost imperceptible frequencies? Until relatively recently, capturing a signal from a distant galaxy seemed an impossible task. How can one hear a cosmic whisper lost in the noise of the cosmos, drowned out by billions of other, closer, and more powerful emissions? These are the kinds of questions that have driven generations of astronomers to push the limits of technology, science, and even our imagination. The challenge becomes even greater when studying remote galaxies so distant that their light and signals take billions of years to reach us. At such immense distances, even radio waves, one of the most effective tools for probing the cosmos, weaken to the point of being nearly imperceptible. It's like trying to spot a lit candle from across a continent shrouded in darkness. Yet, against all odds, a group of researchers has achieved the unthinkable. Using the Giant Microwave Radio Telescope, GMRT, in India, they captured a radio signal from a galaxy so distant it hails from a time when the universe was less than half its current age. The galaxy, named SDSS J0826+5630, is located nearly 9 billion light-years away from Earth. The detected radio signal, known as the 21-centimeter line, was emitted about 4.9 billion years after the Big Bang, a period when the first galaxies were still forming, and the universe was a vastly different place from what we know today. What makes this 21-centimeter line so special? This specific wavelength is emitted by neutral hydrogen atoms, one of the most abundant and fundamental elements of the primordial universe. When a neutral hydrogen atom changes its energy state, it releases a tiny amount of energy in the form of a radio wave with a 21-centimeter wavelength. For astronomers, this signal is like a cosmic fingerprint. It not only reveals the presence of neutral hydrogen, the fuel for star formation, but also allows them to study galaxies and their gas content at distances otherwise unreachable. Until now, this type of signal had only been detected from galaxies relatively close to Earth, as more distant signals were too weak to be captured. This new discovery, made possible by the gravitational lensing effect, has radically changed the landscape of radio astronomy. Gravitational lensing is a phenomenon predicted by Einstein's theory of general relativity. When an extremely massive object, such as a cluster of galaxies, lies along the line of sight between a distant source and an observer, its gravity warps the surrounding spacetime. This can amplify the light or radio waves from more distant objects, much like a magnifying glass focuses the light of a candle. Thanks to this phenomenon, the signal from galaxy SDSS J0826+563 was amplified enough to be detected by terrestrial instruments. This extraordinary result not only confirms the power of gravitational lensing, but also opens up new possibilities for studying even more distant galaxies. The composition of the galaxy revealed a surprising detail. Its atomic gas mass is almost double the mass of all its visible stars. This means that in its youth, galaxy SDSS J0826+563 was incredibly rich in the materials needed for new star formation. It was an era of intense activity, laying the foundations for the structures we observe today. Observing such a distant galaxy is equivalent to traveling back in time. When we look at SDSS J0826+563, we don't see it as it is today, but as it was nearly 9 billion years ago. This allows us to explore the conditions of the universe in distant epochs and study how the first galaxies contributed to shaping cosmic evolution. This discovery is only the beginning. Future instruments, such as the Square Kilometre Array, SKA, promise to push the boundaries even further, enabling us to study even older galaxies and construct a detailed map of the primordial universe. Every new discovery brings us closer to answering fundamental questions. How did the first galaxies form? What processes gave rise to the first stars? And how did the cosmos evolve into what we know today? This story reminds us that the universe is a place of infinite wonders. Every new discovery is a testament to human curiosity, and our ability to surpass the limits of the possible. As we continue to explore the cosmos, we are driven not only by the thirst for knowledge, but also by a sense of awe for the vastness and beauty of the universe. Thank you for watching. Don't forget to like the video, subscribe to the channel, and activate the notification bell to stay updated on future content.